Quadratic formula. Uh, we're gonna prove it here in a second. But first, I'm just gonna write down the general equation, which is negative b plus or minus b squared minus 4ac divided by 2a. I'm gonna go through multiple approaches, because some don't make sense to me. Because although you get it through algebraic manipulation, some require squaring a variable and then square rooting a variable, which is not the same thing. And we'll get to that in a second. It gives you the same number numerically, but the sign is not the same. For example, if we take negative 2, square it, and then square root it, that's the same thing as 2. If you do 2 as well, square root it, and square root it, you'll get 2. So it's a little tricky because negative 2 just by itself is negative 2, so you can't just cancel these out. And that's kind of what the quadratic formula assumes in my approach from what I've done from it. But here's what we're going to do. First, we're just going to subtract c to the other side, giving us x squared plus bx equals negative c. Pretty easy. Divide everything by a. X squared plus bx equals negative c over a. Now, sorry, and then b over ax. Now we're going to complete the square. And I guess you can solve it any other way as well, as long as you complete the square. As we know, completing the square is adding b over 2 squared to both sides. So we're going to do so. So it's b over 2a squared equals negative c over a plus b over 2a squared. That's the same thing as x plus b over 2a squared using the property rule. I can literally explain that out and show you, but if you guys are familiar with completing the square, then you have that, and you do negative c over a plus b over 2a squared. Doing some simple algebraic manipulation, we can get that to equal negative c over a plus b squared over 4a squared. Nothing bad. Everything matches up so far because we haven't got the square rooting and squares, and those are just so complicated because they're not the same thing. You can't square and then square root. That doesn't give you the same thing as a sign. It gives you the same number, which goes back to the negative 2 example we used earlier. But now let's get negative c over a to have the same denominator. And to do so, we'll just do negative c a. We'll times a on both sides at the bottom, because this is just a over a is just 1. And then we'll times 4 on the top and bottom as well, giving us negative 4ac, which kind of looks similar to this term, which we'll get to. And now, since they have the same denominator, we can just add them together. So it's going to be b squared minus 4ac over 4a squared. So now it looks a little strange, because in the bottom there's 2a, but we'll get to that later. Now let's square root on both sides. And let me just move these terms to the left, because it's a little complicated to understand. And this is a really simple quadratic formula proof. I thought it would be something with like derivatives, kind of like the line of least squares regression, but no, this is a lot simpler. We'll square root both sides, and there's nothing wrong with this right now. And when we square root both sides, make sure it's plus or minus. The reason being that regardless of the inside could be negative or plus. It doesn't change that. So it's the same thing over here. This side could also be plus or minus, because let's say if we have x squared equals 4 and we square root both sides, it's not just square root 4. It's plus or minus square root 4, because negative 2 squared is also 4. So that's the logic behind it, and that's a lot of people seem to miss that, but no, it's just simple logic. Then we subtract b minus 2a on both sides, or b over 2a on both sides. And now here's where it gets a little complicated. We multiply 2a on both sides, giving us 2ax, because we just moved that term over, equals negative b plus or minus 2a square root, and then I guess the determinant. Oh, gosh, it's a little messy, but it's okay. But here's where the issue comes apart. And I'm not sure. I guess we could fix it by squaring both sides, but that makes it even more complicated. What you can rewrite 2a as is the square root of 4a squared. But that only assumes that, 4a squared, yes, 4a squared. But that only assumes that a is positive, because if a is negative, then that does not equal that. So, I guess that's the weird logic behind it. I'm thinking. Yeah, I don't know. I guess I'll leave that for someone else to find. I'm sure it's figured out already. But 2a does not equal square root 4a squared. And that's kind of the issue behind it. So, since this is the same thing, we can rewrite this as negative b plus or minus square root 4a squared, which just cancels out, because you can just multiply if it's the same power. Which cancels this out, giving us just b squared minus 4ac, so it's going to be 2ax equals negative b plus or minus square root b squared minus 4ac. It's a little messy now. And now you just divide 2a by both sides to get your traditional formula. But I'm going to hope someone manages to find what I'm curious about. Otherwise, I'm going to have to ask my teacher. So, x equals negative b plus or minus b squared minus 4ac divided by 2a. Formula proved. But, except for this part, which I guess I'll do some... By the way, I figured that out right there by myself. So, it's probably not the right way, based off what just happened to me. So, like, this was my approach of finding the quadratic formula. I mean, the first half wasn't mine. I found that online. But I can use algebraic manipulation starting from this point right here. And I managed to find it this way. So, if this is a different approach to the quadratic formula, then there it is. I didn't search that up. But, the issue is with this... Okay. The issue is with this conjecture right here, because this is not true. It's only true when a is greater than 0. So, someone's going to figure that out, and it's not going to be me. Maybe it might be me, I don't know. Thank you.